Okay, so today we would start working on solving the problem on count number of maximum bitwise or subset. So basically, we would be given an integer array nums, and we would like to find the maximum possible bitwise or of a subset of nums, and then we would return the number of different non-empty subsets with the maximum bitwise or. So the first thing that we would like to do is we have to first find the maximum possible bitwise or of the subset of nums, and then we have to return the count of different non-empty subsets with the maximum bitwise or. So basically an array A is a subset of an array B if A can be obtained from B by deleting some elements of B. So from a given array, if you want to have if you want to find some subset, we can delete some number, some object from the given subset, and then two subsets are considered different if the index of the element chosen are different. So basically with the same subset, having the same numbers, they can be considered as different if we have the order of the sequence of the numbers in the subset as different. So that would be a valid subset. So bitwise or of an array A is equal to A0 or A1 or like this. So for example, let's say we have for 2. So basically for 2 the bitwise representation is 1 0. For 3 it is 1 1. So now if you want to have 2, if you want to find OR of 2 and 3, then we would get 1 1. So for example, for 0 OR of 1 it's 1, for 1 1 it's 1 1. So what you can do is, so using Kotlin, what we can do is we can define two global variable, which would be, for example, private var max or, and that will be 0, and then the other object that we can define is the count. So private var count is equal to 0. Now we can define the function which is fun. I'll copy it. So basically this is what we would like to proceed with solving this problem, where we have to find the count of max or subset. So basically for a given subset where we are considering a given number to be included into the subset or not, the ideal approach would be using backtracking. So using backtracking, we would be solving this problem statement. Now what we can do is, so for this problem statement, we can find the max or of the different numbers of the OR of those subset. So for this, what we can do is we can consider each and every element of the array, and considering each and every element of the array, we can find their maximum OR. The reason is, like, if you have already found for a given subset of numbers for their maximum OR value, and if you are still finding for some another number, in that case as well, the max OR won't get changed. It is always going to be the maximum of it, even though if you're performing some OR operations with other subsets of the other numbers in the given subset. So in this case, what you can do is, I'll iterate with the for loop. So for num in nums, so max OR is equal to num or max OR. Okay, here I'll change to small r. Okay, so from this we will be able to get the maximum of max OR of all the given numbers in the integer array. Now what you can do is you can perform a backtracking. So with backtrack, what you can do is, with the given nums array, we would like to start from a given index, and then we would like to start with a 0 as the current OR value, and then what you can do is we can return the count. Okay, so in this case, what you can do is, I'll create a function backtrack where we have the given numbers as integer array, and then I will start with as index, and then after this index have been identified, this would be the current OR value. So in this case, what you can do is, uh, for example, let's say if we are on the right end of the given index, in this case what you can do is we will have a one check. So if index is equal to nums of size, in this case what we can do, we can again check the check would be like, if the current OR equals to max of OR, in this case we will increment the count, and once the count have been incremented, we'll perform a return statement. And then what we can do is we can perform a backtrack with including and without including the current index. So in this case, nums would be my current index, current integer array, and index would be +1. So index +1, and then we would be using the current number to have the current OR value. So in this case, the current OR will be our current OR, then OR, and then here we have the current index, so nums of index. So this would be my current backtrack statement. Now after this, what you can do is we can perform another backtracking without including the current, without performing the current OR operation on the given number index. So in this case, it would be backtrack, then nums, then followed by index +1, and then we would not be performing the OR operation. In this case, it would be current of OR. So basically, with this given approach, we would like to perform two sequences of backtracking, one with performing a subset which would be including into the current subset the index of the number for which we are calculating the current OR value, and for the other one, for the other subarray, we would like to exclude this number. So once we'll be running this, we would be able to solve this problem. So that should be it for the given approach. So this would be the approach that we would follow for 2044 count number of maximum bitwise OR subsets using backtracking approach. So backtracking will give us the ability to include or do not include the given index of the number from the integer array. So that should be it, guys. Thank you, everyone.